My name's Alan Konecnik, and I'm with Sunnen Products Company. I am a senior lab tech here. Actually, my job is more of going out and training people on how to use their equipment, new equipment that they've purchased, to get them to use that properly. Help if some shops every once in a while, of course, will lose an employee and then they need some help getting going again. That is one of my jobs. The other part of my job is I do answer the tech line here, kind of like the AERA tech line. When you call Sunnen, there's a good chance that I will answer the phone. And the other part of the job is if a customer comes and says, hey, we want to be able to hone this part and achieve this tolerance and this surface finish, then my job is to figure out how to make that happen and what machine to use and how to get that to work. And with that being said, we talked about, I titled this Homehead Maintenance and How It Affects Board Geometry. And I guess when I used the word geometry, I had something just a little bit different in mind, not only geometry meaning just round and straight, but you could look at geometry meaning issues with size. People call and say, hey, I'm always undersized or oversized, or geometry referring to, which is more of the surface finish areas. How do I get my certain surface finish parameters? So those are things that I want to talk about. The Homehead itself can actually have a fairly major effect where things were going really good and all of a sudden they started heading south, and how do we fix that? So with that being said, what I would like to talk about, because the audience through AERA is pretty diverse, from very small, maybe a one-man shop, to to the Jaspers of the world, the great big players. So I want to talk about basically most of our automotive style of home heads. So the old AN style, which is the portable one that everybody thinks about, I think, when they think of Sunnen, where you can use actually an electric drill, or you can have a remote feed system, to the CK-CV Homeheads. That's the most common if you've had a CK10 or a CV616 or an SV10 or 15. When the SV10 and SV15 came out, we also came out with the DH series Homehead. The DH was a little bit more affordable version of the GHSS and GHTS, with the GHSS being single stage and the TS being a two-stage, where we could carry both the semi-finish and the finish stones on the same head. So you have a push-pull mechanism there. So with that being said, we'll move on and kind of take a look at the AN style hone. I think most everybody out there has seen one of these, or maybe even everybody has one laying on a toolbox because you just have a lawnmower that you want to do, or just something. What's nice about these is obviously they will run on a drill press. There are a lot of other manufacturers of honing machines that use this style of hone head with the remote feed, the one that has a silver disc up at the top so you can feed it while it's running. I took the approach of the very most simple one here. The things that we get questions on are, hey, all of a sudden I can't hit size, or it quit honing, or my stones are wearing funny, or I can't get any load build up on the cylinder. So things that we want to look for, where it says hone body holes are worn. If you can look at right in this area of the body itself where the pins come through. Well, those, when they come from us at the manufacturer, they're nice and round. And after 10 or 15 years of use, because you keep in mind that this is being used in an environment with oil and grit and cast iron, which is a lapping compound, if you will, those holes start to wear and they actually become like a football. That lets the stone and everything wobble within the body. So that is a problem. If you look at the gear up here on the top, they should have nice, sharp, defined teeth. When the teeth start to get wore on one side, they mate up here, and the teeth then will start to jump or not lock up, and therefore you can't keep pressure. The pinion itself that comes down through all the rack gears. Literally last week I was setting up, it was a tube home, but the customer had this, and you could see on here 4 distinct spots where the long pinion teeth were almost worn all the way through. They were that worn out, and that just allows a lot of backlash and play, very hard to control shape of the bore and stock removal. So those are the 3 things that we were talking about on this part of the Homehead. If we go on, another real common thing is the hole here. There's a screw that sets in here, which comes into the side of the body. When these get worn out and look like footballs, again, that's going to allow the whole mechanism to orbit and not spin about a center, which causes loads on the side of the stone and can cause taper. In this particular Homehead, the sides over here, they're put in with like a rivet, but again, if they get worn and this is sloppy, you will have the same problem. Another large, not a large issue, but things that are a little bit harder to find is this pin right here goes through and holds that body gear that we just saw on the last slide. And not so much on hand feed hones, but on remote feed hones, you can apply enough pressure that you will actually take that gear that's up at the top and you will spin it and it will shear this pin. So the gear will move independent, but when it starts doing that, you can't apply any pressure to the stone. So it'll act like it wants to apply pressure, and then it'll give away. And what you have to do is look to see if that pin had been sheared off on the inside. It's a simple fix. You take a little 1/8" pin punch that all the way through the center, get another pin from us, you put the pin in, drive it till it's flush, and away you go. I know this will seem pretty basic, but the hone body has X's marked on it. And wherever there's an X, that's where your guide shoes or your stones go, and the rack gear faces inward. I'll get probably literally a call a week going, I don't know what's wrong, but some of my stones are trying to go out and some are trying to go in all at the same time. How is that possible? Well, you've got them in the wrong positions. Other times people say, hey, I can't get the pinion to slide down through the body, and that's because they have them in the wrong position or inserted the wrong way to where there's the round part of the shaft there's just no way for the teeth to go through from the pinion. And those are the major things that we see with this style of Homehead. On the so if we move on in basically the iteration of the Homeheads is more the CK or CV style. And the reason I listed it this way is we get a ton of questions. Hey, I just bought some guide shoes and they don't fit. Well, the Homehead itself is virtually the same between a CV and a CK. A CV will have a longer shaft because that was the industrial version. The CK has the shorter shaft because we typically are honing blocks and we don't have a real large variation in cylinder lengths. And the stones and the guide shoes, the holders, if you look at your holder, it will start with either CK or CV. They are interchangeable. They all will go in the same Homehead, but the big difference is CK tooling was set up for automotive shops. And if you look on the guide shoe, one guide shoe, it will offset the bronze guide shoe down about 1/4 of an inch. And that is done for a reason. We have main webs that get in the way of the bottom of our bore. So rather than going through and trying to increase your bottom overstroke and hitting with the entire stone holder and doing damage, you go down there and you just kind of thump it with the end of that brass guide shoe. So that is why we have the CK tool. That's the difference. Is the one guide shoe actually. If you have CVs, there's no reason to change. Just be careful of the bottom of the stroke. So that is the major difference, at least between a CK style head and a CV style head. The items that we would like to look at, and this was actually sent to me when somebody found out that I was going to be doing this presentation, came off of Facebook. Anyone know why new stones are doing this on 3 blocks? This stone here is thin at the top, thick at the bottom. The other stone is thick at the top and thin at the bottom. They're wearing opposites. Well, there are some very easy ways to fix that. One of them is, we'll show you in the next slide, is the universal joint up at the top of the block. But one thing we can see here too is if I look at this picture, you can see there's really not many shims here. On the old, anybody that's out there that has an old CV or even an old CK10, we used to tell you to shim the guide shoes, and then you would either put a thin shim, a thick shim, or no shim under the stone itself. Well, since then, we've decided that there's a much better way to do that. I mean, this has been out since probably 1975, somewhere in there, where you will actually shim the stones and the guide shoes both to the number 2. You don't want to shim them to 0 because 2 things that are the same size won't actually go together. So you need just a little bit of clearance so you can drop the hone head in. But that's what the shims do. So we want to be sure to shim the stones and the guide shoes the same amount. So this was, like I said, this was just a question that was literally posted out on the internet. And we get that again. That comes in about once a week. This is what we were talking about. We're going to shim both the shoes and the guides to a 2 on our setting fixture. If you look at the old style shim set, there's just 4 holes in it. When we went to the new style shim set, there's just the 2 extra holes on the end. Yep, the question is, can I drill my own shims out? Sure you can, no problem. And then you can use your old ones like the new ones. It does get a little bit hard to start to drill on those number 1, 2s, 3s. They're so thin, it's like trying to drill through sheet metal, but it obviously can be done. So it is important to go ahead and make sure that you shim them the proper way. Most people, and when I go into shops, you don't see very many people using these upper guide shoes. So the upper guide shoe is mostly important when we're using the roughing stones, because if we're using a roughing stone, the chances are we're in a bore that is used. I mean, we probably didn't just run it through the boring bar. We just were maybe trying to, there's 3 or 4 thousandths wear, we're just going to take it 10 over, so we're going to hone it all the way. Well, what happens is the cylinder wears, right? It wears at the top, it's tight at the bottom. When we're honing, just this bottom part of the stone gets into the cylinder, gets into the tight part of the cylinder, and the upper part of the stone kind of theoretically isn't really touching. So it allows the hone head to start to wobble and to oscillate around. Therefore, starts to wear, one stone will wear thin at the top and thick at the bottom, and the one on the other side wears just the opposite. So if we would put this other piece, this other small guide shoe in, that gets it right up next to the pivot point and won't allow that hone head to rock as much, and the guide shoe doesn't wear out as fast. The question a lot is, how do we set these? We set this in our stones inserter, or I'm sorry, our stone setting fixture. Set this up against the edge. We set it to a number 2. We slide this adjustment bar and tighten the set screw, and it's done. And then we pop them into place. That's all there is to setting those upper guide shoes. They don't need to be used as much when you're running a finishing stone. Reason for that being, if I'm on a finishing stone, chances are I've already got my cylinder straight round, so that will help. But all we're trying to do when we put these other small guide shoes in is to get up closer to the pivot point. The closer I can have my stone to the pivot point, the better I am. If I look at this picture, question would be, is that a CK or a CV? I don't need to see the back to know. I can see where my guide shoe, where my guide is hanging over the holder a little bit, so I know that this is automatically a CK style of guide shoe. And it only is done on the one guide shoe. Okay. The other thing that causes that taper is when we get to the top up here, our universal joint, when these holes here and here begin to wear, or the bolt themselves that goes in begins to wear, that creates a lot of play and allows the universal joint to wobble and kind of bind. So once it starts to bind up a little bit, then it causes load and gets this hone head cocking. A little better picture of that universal ring. This particular one is not worn out, but you'll see these to where you'll see one side is real thin up here. You'll see them to where they're oblong, just like a football. You'll be able to look at the top of this attaching bolt or screw, whatever you call it, where you can see that they're completely worn also. And this is replaceable. You can order this part. You get 4 screws in a ring, put it all back together, and my guess is that very first picture that I showed you, that the gentleman would replace that ring and possibly put the upper guide shoes in, since it looked like he had a roughing stone in there, his problem would go away. Other things, we talked about it a little bit, is we start to get wear in the bodies themselves where these holes become oblong. That's an issue. The only repair is replacement of the body itself. Other things that we do see over time, not very often, but you can see wear on the actual wedge itself. But where we see a problem more commonly are the push pins. And on these push pins, they rub against here on the wedge angle and then push the stone out. Well, this is all in a nasty environment again, right? Oil, grit from the worn abrasive, cast iron particles, so it's a lapping paste, and they start to wear these push pins. And we sell the push pins as a set of 4. The problem is there's actually 3 of them are different, and there is a very specific way in which each pin goes into a location. 2 of them are close together like this one, and then on the other side they're a little farther apart. When you get that set, or if you need information, you can reach out to us here at Sunnen. I'll have my contact information at the end of the show. And there's a piece of paper that shows you a picture of what each of the push pins looks like, the orientation, and the location of where they go. But if you take it apart, put it together wrong, it's not going to hone a straight hole either. Okay. So from the CV, CK style of hone heads, it's kind of a little bit backwards. We initially had the GH style hone heads, which I'm going to talk about last. But what happened was the GH style was a very industrial, very robust style of hone head. It works absolutely awesome. Problem was, for smaller shops, it was just a little bit pricey. So what they decided to do was come up with something that was similar, got very similar results, but also was a little bit more affordable, had a little bit more versatility on the size range. Every time we get a quote, not a quote, but every time we get a better or more accurate hone head, the size range of the hone head keeps shrinking. So the first thing we had was the AN. It was like its range is about 2.5 to 6 inches. Well, then we went to the CKCV, about 2.5 to 4.5, 5, kind of depending inches. Well, now on this home head, we really only have a range of about 1 inch per hone body. And the reason is we're making things more rigid. We're having the stone stick out less from the hone body so it doesn't act like a tuning fork. So as you go up in precision, you go down in the amount of size range that you have with the hone head. In our industrial side, if you were going to hone fuel injectors or anything that is very precise, the hone head gets made specifically for the job, specifically for a diameter. Again, price has increased, range has decreased, but accuracy is also increased. Okay, so on this DH style head, there's really, knock on wood, we haven't had too many issues. Most of the issues with the hone head have actually kind of been more user oriented. But when you purchase a DH hone head, you can purchase it as this kit. So you get the upper drive tube, and then you get the inner feed shaft and the cone. Then you can order 1, 2, or 3 bodies, a 70, a 93, and 117 millimeter bodies, depending on the range that you want to hone. And each of these bodies will just slide up on the cone, slide right into the upper drive tube, and you have changed your diameter range as long as you've changed your hone body and the stone set. And all it is 3 little set screws that hold that all together. So to talk about the issues of the DH hone head, really, luckily, like you say, most of them are more user oriented, where we have, a bit of a problem. If we look at our stones and you think about what's happening on this hone head, the stones have that's another reason that this hone is a little less expensive. It's a throwaway or disposable holder and stone. Been doing this for quite a while, and very, very, very rarely do I ever see somebody wear out the stone before they have to buy a new one. Usually they will break it, and that definitely shortens the life. But this is an aluminum casting here, and it will ride on the wedges of the cone. The cone is so hard, we have not seen the cones wear. You'll see the aluminum piece wear here first. The body itself is made from a aluminum, and it, again, the stone itself here will start to wear. We have not had anything wearing out with the bodies. What we do want to make sure of is when you install a stone, the bodies are all marked with location 1, 2, 3, 4 going around them. When you put a stone in, you want to put stone number 1 in location number 1. When you get a set of stones out of the box, it really and truly doesn't matter where you put them in. You're going to true them into that hone head. But if you don't put them in the right locations, so 1 and 1, 2 and 2, then you need to mark which ones you put where. Take a die grinder and put a little mark up on the top of it. This is what I called cylinder. This is what I called stone number 1. This is what I called stone number 2. Make sure that they're located to the proper slot, because if you take them out and put them back in, and you put them in different locations, you will not make a straight and round. Well, you make a round, but you won't make a very straight bore, because the stones become mated to this cone in a specific place, and if we change that, then we change that location. And when we're talking about not as straight, you're talking in the tenths of thousands now. We're not referring to 3 or 4 thousandths difference. It's tenths of thousands. Probably the call that I get the most is there's a thrust bearing that sets here, goes right underneath this, and that then sets on top here. People will take the body off, They will leave the bearing over here, put the next one together, and put this together. And at that point, they'll be calling saying, I'm getting all kinds of size problems. I have huge taper. And that is because the whole cone is shuttling up and down approximately 30 to 40 thousandths inside. So think about it. If I move this up or down 30 thousandths, how much that's moving my stone in and out every stroke. So it's important on the DH that we do get that thrust bearing back in place. Now, on the DH Homehead, we do offer two types of cones for that. And so if you look at it, you have a couple of, more than two types of customers. The original cone that came out was here. And what we were trying to do was to get a home head that covered a large range with a minimal amount of stone sets. Well, what happened then is, of course, when you solve one problem, you create another for yourself. We had the people that were using, the like 4-inch 100 to 4-inch 500 bores, or some type of a hard nickel block or a dart block. And when you start getting to those bigger diameters, sometimes you would get a chatter. So what ended up happening to solve that problem, we created what they called the high feed force cone. And you can see the angle difference between these two cones. And that absolutely rectifies the problem. My personal opinion here is I would just go straight with this cone here, as long as I'm in the size range of that cone. That cone starts at, I believe it's 3 inches, 680 thousandths and up. The downside is, in order to cover an approximately a 1-inch range, I need 3 stone sets over here. Over here, I would need 4 stone sets. So I have to buy more stones to cover the range, but I also know at that point I have more feed force. I can deal with the hard blocks. I can deal with the bigger bores and don't need to worry about the chatter. This is a tremendously hard call to troubleshoot over the phone. Customers have both. And somewhere along the way, this is supposed to look like this: a high feed force on a high feed force cone, a standard on a standard. They will mix their stones up, and they will try to put a standard on a high feed force or vice versa. You can see the angles don't match up very good. This is very difficult to work with on the phone, because it starts to work, but then the stones cock and it's creating a ton of taper. And the people work on it for quite a while, and they probably knock the stone out of true while they're working on it. If you're ever in doubt, the easiest thing to do is take the 3 set screws off from around the body, pull the body off, set the stone against the wedge, and make sure that the angles are fitting properly here. Like I say, this is a very common issue for us to get calls and questions on. The other thing that we can talk about with the DH Homehead and the GHSSTS heads that are coming up in a minute are those home heads are both very good for doing 2-stroke engines. The very first home head we showed, the AN home, that will do a 2-stroke engine because we can put a keyway type stone in, or a stone where there's 2 sticks of abrasive and it spaces out. If you just use a single stick of abrasive when you're honing a 2-stroke and you go over the ports, that will actually cause a bit of a washout area in the port. And even worse, you don't want it to tilt, fall in the port, and then create a crash. The DH Homehead is very good for your ability to do blind holes and 2-stroke. Blind hole meaning, of course, it has no bottom. I really think about almost everything we do in automotive as being a blind hole. When I say that, what I mean is, in most cases, if we go down just a little bit too far, we get into a main web. In an outboard boat motor, right, on some of them you don't go down at all, and you're actually into the cylinder head. So either one of those is an application where this style of hone head is superior to the CK. The CK hone head, we can't do blind holes because of the lug that is on the bottom. So it's just something to think about if you're going to be doing two-stroke application or outboard boat motors, which I guess fall into that two-stroke. Okay, so on the GHSS and GHTS type tools, what we're looking at there is a single stage hone head, meaning we just have one set of stones that will come out together. And on a two stage, it's a little bit hard to see in the picture, I apologize, but we'll have three pieces of abrasive, and we'll have 2 or 3 brushes, then 3 sticks of abrasive, and then 2 or 3 brushes. The reason I'm saying 2 or 3 is it would depend on the size of the bore, how many pieces of actual, if it's a 3x2 or 3x3 type hone head. Obviously, the smaller the hone head gets, we can't cram as much abrasive in. The more abrasive, the more points of contact you can put in a bore, the better off you are. We do actually take this style of hone head here and change the cone so that all of these are sticks of abrasive coming out, in which case we will have 12 pieces of abrasive coming out to make 12 points of contact. That has been the roundest hole that we've seen. We have one customer out there who had us modify the head to put 16 pieces of abrasive in, again, just to come out with more points against the cylinder wall. Now, as you do that, the stones get smaller, the stones get very narrow because you can't put 16 pieces of abrasive in there like this. It just would be way too much abrasive for the bore, and it would not hone properly. You would just end up glazing the stone. All of the hone heads we have talked about are capable of applying enough force to distort the bores. It's never a question of, well, I need to push harder. The problem is the blocks breathe and move so much. We have core shift to where one side of the cylinder wall might be 80,000 stick and the other side might be 240,000 stick because the core shifted during manufacture. When you do that, the only way to hone that straight is with more support and less pressure if possible. No matter whose hone head it is, when you get to the DH style or this style here where you're going mostly to super abrasives, to diamond or borzon, you can kind of say that it requires about twice the force to get those to cut as the old CK standard abrasive, JHU 623 or 618 or a J65 or J85 stone. The super abrasive requires more force to get that to cut. Okay. These have a few more pieces, a few more intricate pieces than the DH. We have the U joint on the hone head binding. So this U joint in here, it can get contaminated and can get rusty. Is you have this pivot point has rust. We have rust here. In the case of the PERs, where a lot of these are, they just have so many thousands of holes on them that they start to get wear in the flanges on both the upper and the lower, on the upper drive tube and on the body of the hone head itself. They will start to get wear that shows on the block. You can get wear in this block here around this hole. This pin can also become worn. And that's what we were talking about here. Tabs on the hone head or drive tube, referring to these tabs here, and the U-joint and the pivot block. And I don't want to make it sound like these things have a ton of issues. We're talking after many tens of thousands of holes, or maybe lack of maintenance. That's where we're going back to this whole thing. If we don't keep things maintained, there is a big rubber boot that goes around all this. This should all get packed with grease when it's assembled to help keep it lubricated and keep the wear down. When these blocks become worn or these ears become worn here, again, the hone head starts to oscillate in the bore. You can actually get some movement in the body. So we'll see roundness issues. We can see cylinders honing tapered because of items like that. On the next. Okay, the lower U joint here and this U joint here, these can become worn. I guess it's been about a month ago now, I was at a shop to where this universal joint actually had worn all the way through one side. It was binding up, so size was varying all over the place. If you think about what happens inside this hone head, we have a female tube that slides over this hex shaft, which goes up into the feed motor. We have this universal joint. We then have a feed screw, we'll show you that in a second, and a retainer block, and then we put a wedge plate on there. And we're trying to repeat within tenths of a thousandth of an inch. So you're talking about, if you're a tenth of a thousandth on diameter, you're talking about 50 millionths in movement in here. So you can see where wear or things getting sticky. On these, the same thing. We don't really see these pads wear, but we have seen some slot, again, from the PERs, the slots can get worn, the ears can get worn here. This wedge plate that goes in, and the cone. The cone is a little bit harder than the wedge plate, so the wedge plate angles can get worn, but you can get grooves worn on the cone. All things to look for if you're not able to hold your straightness, your roundness, what's causing it. I would say especially oil, but I don't think that's true because water-based is the same way. If you let your hone head sit and get gummy because, okay, you don't use this hone head as much as the other one, all these plates need to be able to move in and out of the slots freely. The stone holders themselves, they need to be able to move in and out freely. The only thing, we'll show that in another slide, the only thing that pulls these stones back in is a little girdle spring at the top and the bottom. So if these are sticky and won't pull back in, that'll cause drag marks. There's a question, what's wrong with my hone head? There's a vertical drag mark coming out. Well, if there's only one, that's kind of telling me that either you don't have it aligned properly or one stone is kind of sticking and it's not collapsing in when I remove the hone head. Here, this is a simple replacement. If this is worn, it's just a replacement of that part itself. So those are all items that need to be looked at and maintained. And the problem is most of the time we don't start looking at those and worried about maintaining them until all of a sudden I can't hold size, I can't get surface finish, I've got a tapered hole. Initially, when the hone head came out, this was the feed screw that was in there. And what can happen if you feed it too much or you hit the bottom of the board, there's the little pin that goes through here, comes right through here. So that will feed up underneath the pin goes through, and you'll snap that pin. And that is one way that we can find out that we're honing oversized, because the feed rod slips and it keeps moving into a different location. So the encoder on the top of the machine has kind of lost its position. It keeps trying to go to where it's supposed to, but it's a different location on the feed screw. This hole right here is really important. To go back again, there's this hole right here. Here lines up with that hole here, and there's a set screw, a dog point set screw that goes through there. Over time of thousands of cycles, and if you hit the bottom and drive the wedge up, this will become elongated. And that allows this whole puck to move up and down. If the whole puck moves up and down, so does the screw. That's what moves the wedge. So when this whole thing is shimmying up and down, my stones are going in and out. So that creates again, a taper problem. It can create size problems. This is the only side too. If this is moving in and out, this will allow me to cut oversize. Hey, my first 3 bores were right on. My next bore was 2/1000 over. Why is that? That's because I probably have some clearance or elongated here, or the set screws are loose. Then, as the 2-stage hone head came about, where we have a push-pull, so we have to move that wedge so far in each direction and repeat, we actually have a new version, a heavier duty version, and it's called the BP, or bearing pack. So instead of just having this floating here and then there's a little thrust washer up on the top, we actually have a bearing assembly in here. Also, you notice the top of the feed screw is no longer just held with a pin, it's a hex. So this quit breaking completely. No issues there whatsoever. But what you can do is destroy the bearing. Same thing applies. We have a small tapered screw that is designed to screw into here and be tight and hold any shuttling down. If those screws break, you'll see all kinds of size variations. The nice thing is on this one, you pull the screw out of the body, pull the tip, get the tip to pop out, put the new screw in, and you're back in business. So this is the heavier duty version. As we were talking about the retaining springs, if we look at this retaining spring, it's fairly heavy. So if there's a little bit of goo on here, it kind of will have enough force to overcome it. But this little spring is tiny, and it has to take care of both the brushes and the stones. And with it being so small, you have to make sure that all of these are sliding easily. Okay. Now, I know the talk was supposed to be about hone heads and how their maintenance or lack of maintenance will affect geometry, but there's also some things with the actual machine themselves, some basic things. The upper U-joint, it will have the same exact problem as the U-joint on the hone heads. So if it's binding or not lubricated or got rusty, as it binds, think about the U-joint on your drive shaft, right? You can feel it turn and it binds up, it breaks free, gets loose, binds up. Well, if the hone head's doing that, it starts oscillating, and then hence the problem in the bore. Another one that we see fairly often is feed rate set improperly or not working. Man, we could talk about all kinds of feed rates, but you have the mechanical feed rate in like an SV machine. It only feeds on the downstroke, and it's supposed to try to grab a tooth, hone until the next tooth comes around, grab another tooth. And if I have that set too fast, I'm ratcheting too fast, I'm plowing everything out way too fast, I can watch my load meter and it just keeps climbing. Or maybe I have the U-joint, the U-joint on the inner feed shaft is broken, and I never get load, but the crown is moving. Well, that's because it's not pushing out on the stones themselves. So it's not working. In the case of the newer machines, feed rate set improperly, maybe I wanted it to feed at 0.001. I wanted it to feed at 1,000ths a minute, but I inadvertently put in 0.01. So now I'm feeding at 10,000ths a minute. Machine will do it absolutely no problem. Something's going to give, either the block or the some piece inside the hone head, or more than anything, you'll just see a huge problem with the geometry on your cylinder. Contaminated oil or coolant. On there, what we're meaning is oil. The oil itself typically doesn't really go bad if you have like an MV30 or MAN 845 oil, but you have to think about over hundreds and hundreds of blocks, you keep putting abrasive in there and cast iron dust from the hone. Are you keeping up with your filters? On the coolant side, everybody's liking to go to coolant now. Of course, if you have coolant, you cannot run standard abrasive stones. But with coolant, if you don't keep the refract or the percentage right, if you let the water evaporate out, the refract goes too high, and now you'll probably see your surface finishes get much finer because it gets slicker. It's hard to cut. If you pour too much water in, the refract will go low, and you might even see your surface finishes get too rough. So just the coolant can affect the surface finish. Same thing with cutting. If you have too rich of coolant, I have to push too hard with the diamonds to try to get them to penetrate, that I'm distorting the block. That will all come in as part of, I say incorrect coolant refract, meaning that it's just not set properly, or you don't have enough water or chemical in at that point. At that point, I'm probably going to end up being a little bit short. I apologize. But my name is Alan Konecnik. The cstech@sunnen.com. This is the best email address to use. So we have somebody on the phones every day. Some days it is me. If it comes in and you direct it to me, whoever is on CS Tech will forward that to me, because if I'm out on the road, I wouldn't see it. And then, I will try to get back with you as soon as possible. The same thing, if you want to call and talk to somebody, this is the best way to get into our tech line. Again, if you absolutely need to speak with me, not a problem. Leave your number with the gentleman on the phone, and he'll track me down wherever I'm at, get it to me, and as soon as I get a chance, I'll be happy to give you a call back and see if we can discuss your problems. With that, that's all I know.
Super, Alan. No, thank you very much. Excellent presentation. Definitely addressing some of the, again, your presentation is just one of those ones where unless you're popping into the shop and actually hands-on with somebody right there on the machine, this is information that's very well needed in our industry. So thank you again, much appreciated for sure. We do have a couple questions that have come in.
Okay.
Sure. So first question. So on the HSS Home Head, is there a recommended maintenance PM, like checking these parts weekly, monthly, yearly, etc.?
No, not really, because the problem with giving a weekly, monthly thing is, maybe I don't use it for a month. So if you didn't use it for a month, then there'd be no reason, of course, to check it. I think more of it is when you start to see a problem. If the big thing I think on the GHSS, as long as you can grab the stones themselves and get them to make sure they move in and out, and that the wedge plates move in and out. And something, I apologize, I forgot to mention, when you take that hone head apart, those wedge plates are numbered just like the stones. The wedge plates have to go back in the same location you took them out of. So not only do the stones need to go back, but so do the wedge plates. I apologize, I did not say that when we were talking about taking those apart.
Okay, all right. Alan, here's one for you. I think this is referring to some of the older stuff too, but how do you know when it's time to change the honing oil?
Well, they didn't say which oil by any chance, did they?
No, they didn't. They just asked. Okay. Yeah, actually, the same person's asked for. It looks like probably for the CK series. So they got another question here about the CK series machine. So they're probably referring to that CK series.
Probably talking about MAN 845. And I guess this is probably the one thing the sales people don't ever want to hear. There's really not a reason to change the oil. That particular oil, MAN 845, MB30, really and truly don't go bad. With that being said, part of the reason is, right, every time I hone a block, I take that block out and a little bit of oil carries out with it. Well, eventually my reservoir goes down, so what do? I pour more oil in. But when I pour the more oil in, then that puts the additive package back in there. So that kind of keeps everything going. You know, in all honesty, if you've been running MAN 845 or even MB30 and you're pushing, 5 or 6 years, it wouldn't hurt you to clean it out and recharge with fresh oil. But I would not say that the oil itself would go bad. Now, if you're using some of like a MAN 852, like a vegetable-based oil, now you have a life of 12 to maybe 18 months, just kind of depending upon the environment you're in, how hot it is, because that's just a vegetable oil type. So it will start to sour and go bad.
Okay, all right. So this one's also in regards to the CK series machines. How often should you be swapping the stones from side to side, or is that important?
Well, if you have it shimmed and everything, it's not all that important. I know there are people that say, "Oh, I like to swap them every block." You're not going to hurt anything. But if your universal joint is good, if you're using the upper guide shoes when you're roughing, you really shouldn't have to. But I know there's so many people out there that just say, well, you need to. Okay, it's not going to hurt anything.
Okay.
And
all right.
Rob, I was trying to put my picture back up on there, and am I still there? Because all I see is my slideshow. I was trying to.
Yeah, you're like your webcam's up. We can still see you for sure. Yep, I know you can't because you're in presentation mode, but we still got you on there.
Okay,
for sure.
Okay.
Yep. No, you're good. What's another question? We've got another one here for you. Looks like probably one of the last questions, Alan, for you. And I guess this is probably, they're saying if the cylinders are glazing up while you're honing with stones, should you be adding more stone pressure or less?
Okay. I'd have to ask a little bit more on that question. Can they tell me what stones they're using or what hone head? And I'll answer it based on whichever. But so if they were using an AN style hone, the chances are that what has happened is they wore the stones down and now the guide shoes are touching too hard. So the way an AN style stone works is the stone touches a cylinder wall and it creates a swarf, right? So we have oil with stone in it and cast iron, and that little slurry follows backwards, and that wears the guide shoe down, and everything wears at the same time. If you go in and you crush the stone, now you've got basically everything touching at the same time. The guide shoes are trying to touch, and there's not enough slurry being made. So what they can do is take those guide shoes off and go to a file, a belt sander, a mill, however accurate they want to be. It's not all that critical. Take about 10 thousandths off of each one, or so you have about 10 thousandths clearance, put them back together, and at that point they may start honing again. If the other reason, like if it's a CK and it quit honing, a lot of times people will try to buy the harder stone. So instead of a 623, you get a 625, with in mind that will last longer, and it will, but the problem is that it becomes too hard. I really would recommend that whenever in doubt, try to use I want to be careful here when I say this, use the softest stone possible. I'm referring to honing blocks at this point. If I can use like a J63 instead of a J65 stone, I will do that. Yes, the stone will wear faster, but it also requires less force on the cylinder wall, which will help me get a rounder, straighter bore and keep the stone from glazing. It sounds like possibly on that first question, or that last question, I'm sorry, I don't, if they got the cylinders glazed, it's probably the guide shoes were rubbing around on there, and now they have to get through that.
Okay, all right. Sounds good, Alan. So that kind of that wraps up sort of all the questions that we had. I just want to thank, Alan, Russ, and Dan, and everybody. Just great job today. Chuck, to win your award, congratulations. That was also really well done. Very, very much deserved. And You guys are all very supportive of AERA, and we really appreciate it. Taking the time to put together the presentations like you did, it was first class, and training and getting this information out to everybody in the industry. This type of networking, I realize it's not face to face. We wish we could have done that with some of the regionals like we normally do, but to have an opportunity to do it in this virtual format, it's still important information. All of our shops and industry need it, and you guys did a really, really good job, and we thank you again. So we normally would we don't have a lot of questions for the final wrap up, so I think what we're going to do, any that we do, we've got a couple, but we'll probably just forward those to the presenters. I know it's getting late here on a Friday. Some of you, especially on Eastern time, are probably looking forward to getting home and getting on with your weekend, and we've got the holidays coming up, so maybe some of you are traveling as well. So we appreciate everybody that tuned in today. And again, I want to thank the presenters for everything that they've done and your presentations today. Congratulations again, Chuck, on your award. And what we'll do is I'm going to go back over to Amanda just here for a minute, and she's going to just wind things up and tell you guys all on how you can contact us and fill out the survey. So Amanda, I'll go back to you here for a sec.
Thanks, Rob. All right, just real quick here. First off, when you leave today, there will be a survey that pops up. If you do have any follow-up questions for any of our presenters, you can enter those there, as well as just let us know how we're doing. If there's anything you'd like to see from AERA webinars in 2021, there's space in there to enter that info as well. Also, you will receive an email from us next week that will have a link to today's webinar. You can go ahead and click that to rewatch something if you missed part of it, or pass it along to other people. It's yours to do with as you would like. And lastly, you'll see our contact information is there for AERA. The 815-526-7600 number will get you to our main line to talk to anybody on the AERA team. And you'll see my email address is there along with Steve, Rob, and Karen. Any of us are happy to help you guys with any questions you may have. Or again, if you have questions for the presenters, we're happy to pass them along. So we just want to thank everybody for taking time out of their Friday to join in our super webinar, and we hope you all have a great rest of your day.